Okay, so we've seen how to define the simplest class, some might say dumbest class in Python. Now let's talk about how would we actually give this user class some attributes. So every user should have a first name and a last name and an email. Let's start there. So how do I actually define that? Well, the first thing we have to talk about is the init method. Anytime we make a new instance of a class, Python will automatically look for the special _init method. So it's going to look for it automatically. You don't ever call it explicitly. And it will call it itself. Whenever we make a new vehicle, in this case, this code will run. So when we make a new user, the user class init method will run. So to prove that to you, let me define this init method. So every time we make a new class, we should have an init method. And one thing I do need to mention, we need to put self here. We'll come back to this self keyword in a moment, but for now, just trust me, it needs to go there. And let's just start by printing a new user has been made, like that, which I guess that's a passive voice, but whatever. And now let's make a couple of users, user 1, user 2, and user 3. I'm never calling init. Python is going to do it for me when I say make a new user. It immediately automatically calls init. Let's prove that. And look at that. A new user has been made was printed 3 times, even though I never actually called init myself. Okay, so that was all just to show, that this code runs when a new user is created. You pretty much would never put a print statement in init. What you would actually do is initialize the data that each user has. And to do that, we need to talk about the word self. The self keyword refers to the specific instance of the user class or whatever class we're working with. So when I refer to self, let's do something like self.name equals, and I could start by setting them all to have the name Perry, for example. But the problem with this, there's no real problem, but it won't actually allow me to illustrate how self works because all 3 of these will have a name called Perry. So instead, let's pass in a name here. Let's go with first. And then I'm going to go with self.name equals first. And now what we have to do is provide a name here when we initialize a user. So let's go with user 1, and let me just do 2 users this time. So the user 1 will be Joe, and user 2 will be Blanca, like this. So what I'm saying is when a new user is created, provide Joe to init. So self always has to be that first parameter. We never actually explicitly pass anything in as self. Python takes care of it. It's sort of behind the scenes magic. So Joe is going to be assigned to the first parameter. And then the word self is going to refer to this exact user here, the specific instance. And then when this user is created, self refers to this user. So it's a way to refer to the individual instances, the current user in this case. So then when I set self.name, I'm setting the name attribute on this user to be Joe, if that's what we pass in, and on this user, it will be Blanca. And if I just execute it now, we don't actually see anything at the end of the day. But if I did a print user1.name, you can see user1 now has the name Joe. So let's expand it a bit. And rather than just doing first, let's also do a last name. And rather than calling it name, let's do first equals first. We'll do self.last equals last. And we'll do age. So self.age equals age. So these do not have to be the same names. This is just the name of a parameter up here. And this is what we'll be using to refer to it, user1.name, or in this case, that won't work. It needs to be .first now to match this. So this is the name of the attribute, like a variable, basically, or a key in a dictionary, and this is the value. Typically, you would name them the same thing, but you don't have to. Okay, so now when I actually initialize a user, I need to pass in other pieces of information, or I'd get an error. This is like any other function. If I don't give the specified number of arguments and there's no defaults, then it's going to cause a problem. So let's go with Joe as first. Let's go with Smith as last, and age will be, 68. And then Blanca, And her last name is Lopez, and she is 41. Okay, so now we have two separate users, two instances of the user class. They all follow the same blueprint. Each one has a first name, a last name, and an age, but they have different pieces of data in each individual instance. So let's now do print user1 and print user2 first. If I just try and print user1 on its own, you'll see all that we see for the representation is this. It's not very helpful. So for now, we're going to access individual properties like first. Okay, and I'll do user1.last as well. And then I'll do the same thing for user2. And let's just see what we get. There we go. Joe Smith, Blanca Lopez. We have two instances of user, the user class. They follow the same pattern, but they have different actual pieces of information. So to wrap that up, we have the init method, and we pass in self as the first parameter always. We don't ever pass it as an argument or anything. It's automatically called whenever a new vehicle, in this case, is instantiated. And the way we instantiate a class is by referencing the name of the class, conventionally capitalized, and then parentheses. And then in those parentheses, we pass in any data, the arguments that correspond to the init parameters. So in this case, V becomes a new vehicle, an instance of the vehicle class with the following pieces of information. Make is Honda, model is Civic, and year is 2017. And then finally, the self keyword. Self refers to the current instance of the class. So it doesn't refer to the class in general, the entire blueprint. It refers to each individual instance every time we instantiate a new class. So we use self a lot inside of init, where we usually take the parameters and then assign them to properties called attributes on self. And in the next video, we'll see that self pops up again because it always is the first parameter, not only to init, but to any methods we go ahead and define on our own class instances. But before we even get there, it's time for an exercise. You're going to define your own class, and then after the exercise, we'll come back and we'll learn to add methods to our classes. Okay, see you then.